Okay, this is number 6. It might be a little noisy because I'm on hall duty, so we'll see how this goes. So we've got the table up here. There's a compound we know and a couple of mystery compounds. So let's do part A. What is the percent by weight of copper and copper sulfide? So we actually don't need the table at all to do this first one, but I think when we get the answer, they want us to fill it in right there and right there. So to figure out the percent weight of copper, we need the mass of copper on top and the total mass of copper sulfide on bottom. So I've added up the total mass, it's 159.3, and copper's mass is 63.54, but of course there are 2 of them in the formula, so I got to multiply it by 2, and then times 100. And my answer comes out to be 79.8%. And I'm going to check sig figs really quickly, although you remember it's mostly going to be determined by the periodic table, so we'd want to have at least that number in there. So I'm going to go with that as the answer. Technically I could probably do one more, so let's do 79.8. Well, I don't have another number in front of me, so we'll say 1 to get to 4 sig figs. In part B, they want to know what is the empirical formula of ore number 2. So we don't know its formula, but we know it's 34% copper, 34% sulfur, and 30% iron. So what we're going to do is we're going to assume that we have a 100-gram sample. So our copper is going to be 34.6 grams. Our iron is, or our sulfur is going to be 34.9 grams. And the iron is going to be 30.5 grams. We're going to convert them all to moles, so we're going to divide by copper's molar mass, which was 63.54, sulfur's molar mass, and the iron's molar mass. So there we go. We divided by the molar masses for all of them. I got 0.544 moles of copper, 1.09 moles of sulfur, and 0.546 moles of iron. So how do we write the empirical formula? Well, you might wonder, well, what order should I do them in? And in this case, there really isn't an acceptable order, but it's got to be Cu, let's say Fe, and S. If you switch the order of those, that'd be fine. Clearly, the copper and the iron are together in a 1-to-1 ratio. It looks to me like sulfur is 2. But you could formalize this by dividing all of these mole amounts by the smallest one, which would be this one. And you'd find that comes out to be 1, that comes out to be 2, and that comes out to be 1. So this is our empirical formula. In part C, they say if sample ore number 3, so we're down on this one now, contains 11 grams of iron, that's that, how many grams of sulfur does it contain? Well, clearly, if 11 grams of it is iron, then more of it's got to be sulfur. We just got to figure out what's the total mass of the sample. It's got to be a lot bigger than 11 grams. So, if I have 16% iron, if I do 0.163 times whatever the total mass was, it would come out to be 11 grams. So I can solve for my total mass by dividing 11 by 0.163, and that'll come out to be my total mass, which is, I lost it here, 67.48. Alright, so now all I got to do is multiply my total mass by the 0.281 of sulfur, and that should tell me how much it contains. So there we go. To find my grams of sulfur, I multiply my 0.281 times the total mass. It comes out to be about 19. And everything else in the table looks like it has 3 sig figs, so I'm going to go 19.0 grams. And then part D, copper can be extracted from copper sulfide by the following process. If 3.84 grams of the oxygen are consumed in the process, how many grams of copper are produced? And I must think they're assuming that oxygen is the limiting reagent here and you have enough copper sulfide. So it's pretty simple, straightforward stoichiometry one. Alright, and here we go. Pretty straightforward. I did the train tracking method, which you can walk your way through. You could, of course, do a before and after diagram if you wanted to. Box our answer and check for sig figs. Everything else on the table has been 3 sig figs. That was 3 sig figs. Actually, we didn't use those, did we? So that was 3 sig figs. Remember, you don't have to worry about the mole ratios of sig figs because they're defined numbers.